Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Mojan.
Hey, Mojan, good to hear from you again. And
Hey, Fred.
We both logged into our call and we scheduled it. So our calendars work, our schedule stayed stable enough that we could actually meet right now. And our Zoom connection worked. We both have power, we both have internet. Zoom in its great magnificence is working. And it's just kind of scary how it just works and it doesn't fail. So how would we gauge the reliability of this system, thinking of it as everything from scheduling to all the IT wizardry that's going on? How would you measure that reliability if we did this for, say, a year and we met every week and it never failed? It just worked.
I love that. I love this thought experiment. Well, for one, I think, figuring out collecting data, of course, is super useful.
Okay, so we
If
did it
that's a
52
possibility.
times for an hour
Yeah.
each and it didn't fail.
Oh, zero
Divide,
failures.
yeah, to
Zero
divide by
failures.
zero is really tough. You kind
Okay.
of frown
Yes.
down in mathematics.
Yes. Yes, I don't like that. Yes. Add is pretty amazing, right? That if that would was a possibility of zero failures. What does one do with zero failures?
Well, we've got plenty of tests.
Mhm.
We've both run into way too many of them that, the vendor says, oh,
Yes.
I tested 77 units from 3 batches and none of them failed. Okay,
Hmm.
so what does that mean? Well, it'll work for the duration of our test under these conditions. Okay, it has
Yeah.
nothing to do with how I'm using your component. So it works for 100 hours in your test chamber. Okay, cool. I can't use that information for anything.
Yeah, what does that mean?
Right. And it's not an
Understandable.
uncommon thing. Is
Hmm.
it's
Hmm.
let's say you're and I've done this where I set up an accelerated life test and we ran 3 different stress conditions and the harshest test condition ran about twice as long as we expected it to. We expected a reasonable probability of failure after, say, 3 weeks. And it went 6 weeks before we got a failure. And my boss is like, hey, we gotta report out on this. We need to know how we're doing. We need to know where we're at. And I'm like, I don't even have a model yet. I had to
Hmm.
assume a bunch of stuff setting up the test.
Hmm.
But okay, we went 6 weeks instead of 3. If the first failure was the same probability given our sample size, that shifts my characteristic life to the right that much, that distance. And I thought, is that loud?
Hmm.
Can I do
Is that
that?
real?
Is that real?
Yeah.
Whereas another way I've used it is, we had a model and we had basically a Weibull plot, a composite Weibull plot for what we expected the field failure rate to be. And rather than saying, oh, after 2 weeks we expect our first failure, it was we have a curve and then we got a failure from the field. And so we plotted it next to that line and it was to the right of the line a little bit.
Hmm.
And we're like, maybe that was shipping delay. Maybe they didn't report it right away. Let's get some more data. And eventually it came up to a line that was just to the right of what we expected, meaning it was just a little bit better. It survived like 2 to 3 weeks longer than we would nominally expect. And so we thought, well, that was decent. We weren't over emphasizing how good it is or how bad it was. As far as we were concerned, we got it pretty darn close. But even with just no failures, and I learned this from Wayne Nelson. He says, well, if you have absolutely no failures and you're trying to see if your test is following your model, assume that in the next instant you have your first failure. And then plot that on the chart saying, all right, after 2 weeks it failed. And here's where it would be. And we have 10 samples, so it's a 10 percentile-ish spot. And I stick that next to my graph. And if it's to the left of my curve, my expected curve, it failed too soon. But I also know it hasn't failed yet. So we wait another day and we kind of creep into where the model is. And then hopefully it
Mm.
goes a little bit to the right, but not too far. And so it was a trick I learned from a statistician is, well, just assume the next instant it fails. Yeah,
So
see
you're
where you're at.
basically artificially adding a failed data point into your model?
Yeah, and just to compare it against what you expect, it's not into the model,
Mm.
it's in a comparison
Yeah.
of it,
Oh, okay, okay, okay. I see, I see.
right?
So it would tell you, okay, so basically, yeah, if your model is earlier, uh, you you know that it hasn't obviously like possibly reached that point, and if your failure is if you I mean, obviously if you see a failure, then
You assume
you can just
failure. Yeah.
add that. Yeah, yeah. Interesting. So why not at that point, are you adjusting the model or
Mm-mm.
you're not adjusting the model?
I don't
You
have
just
any data.
but you can like what if you change your beta, for example, or I don't know, just
It would
because
be,
you can do
yeah,
a
it's more
one parameter
characteristic
variable.
life. Yeah, it
Hmm.
would be a two
Yeah.
parameter and you don't know, you know, I mean, once I get a failure and do failure analysis, then I can say, yeah, it's failing the way we expected it to, the same failure mechanism. So the beta
Hmm.
is the same. If it fails for a completely different failure mechanism, then I need a few more points to figure out has the beta really changed or is it behaving differently for the slope of the failure, the rate of occurrence of failure. But if I don't have any data, right? I have no failures.
Hmm.
And so I can't really check if it failed the same way I expected or not. Now, in some cases, you can, if we expect corrosion or crack growth or cumulative damage of some sort, and we can
Hmm.
measure it, even though it hasn't failed, then we probably are using degradation modeling. And
Yeah.
even before it fails, we have some information. So that's an out when you have nothing. You might be able to, depending on the failure mechanism and your access to the products, measure something that then can indicate whether you're on track or not for that mechanism. But let's say it's, field data and we're not getting the failures back or because we haven't had any failures. We're pretty blind.
Hmm.
My first question almost all the time is, are the customers actually using the product or are they just sticking it over there in the warehouse and hope it goes away?
Yeah. Yeah. Yeah.
There's some of that.
Yeah. Yeah.
But when the boss says, hey, I need to know, yeah, we got no failures, but is that what we expected? Or is it better than we expected? Or where are we? Especially with an accelerated life test. And I say, well, let's assume I have one failure. So I have say a 45-degree line on a Weibull plot, and I have one
Hmm.
point, and I just make up that assumed failure point. And let's say I have 100 samples failing, so it's the first percentile, and it's 3 weeks. And well, if it's to the left of my line, we don't know yet. If it All I know is that it's this reliable. If I draw a parallel line and say, all right, the best I can say right now, if everything's perfect, is it's worse than we expected by this much, but it hasn't failed
Mm.
yet. So we got to wait. And it's the waiting part that, well, you need to test it harder. And 6 months setting this thing up and you approved it. Come on, give me a break. But if the no failures occurs to the right of that projected line or expected line, then we can say, well, we're assuming it fails in the same way as we expect. We're better than we expected. And then the statisticians cannot help anybody sleep well at night. I think that's just
Wait, but
it's
I want to understand better. So what do you do with this information? Like let's say you know let's say the failure point that I mean I can if I'm gonna just artificially assume a failure point, I can put it anywhere. So how
oh
do
no,
you
you can't. No, you
select
can't.
okay,
You have a
okay,
set
how do
number
I
of
pick it?
samples, right?
Okay, yes.
Right? And you're looking
Yes.
at a cumulative distribution function. So let's say you have 100 samples, and
Okay.
if you assume it's the first failure, then there's some fancy little equation that says it's this percentile on the curve. So now you have your x-axis, and you have time on the y-axis or on the
Hmm.
x-axis. You have a percentile and you have time. That's where that point goes.
Ah, I see, I see. Okay, okay, I see, I see. Yeah. So it is within the distribution that you or have assumed,
Hmm.
and then you pick basically a time from from based on where you're at essentially in the life or in the test.
Right,
And then you figure out where that dot lands, and then you compare that to your model. I see now. Okay.
right.
Okay.
And
Yeah.
there's not a great answer. It's either, well, it hasn't failed yet, but if it did fail right now, it'd be worse than we thought, or it'd be better than we thought, assuming that it's the same failure mechanism. So my
Yeah.
boss then usually gnashes his teeth and wondered why he paid for my stats program for classes and stuff. And it's like, we don't know. Give me 20 failures and I'll have a whole lot more information
Yes.
and we're
Yes.
good.
Yeah.
When I was testing ball grid arrays with an accelerated life test, they were working way better than we expected, and
Mm,
and the time was running out. We had to decide: do we use this interconnect system, or we use Gullwing packaging, which is a different spacing and everything else. And up until that point, the circuit boards were designed using both packages. So there was one design for the ball grid, and there was another design with the Gullwing. And there was enough space that it didn't really change the design or the size of the board or anything like that. Because it was just an unknown for this team. And at that
mm,
point, the ball grid arrays have been in use for about a couple of years. So there was some information. Yet for this application, for this consumer product, for mass volume, all this stuff, and this team had no experience with them. So I was asked, will they work in our environment? And so I ran an accelerated test.
hmm.
And it just took forever to fail. And I ended up running the test for almost a year longer than we expected to get enough failure points to see what
Mm,
it really would project. And it was about 10x better than we expected, that we needed, and better than we expected. And so we needed it to have a very low probability of failure out to 5 years. And
mm.
it was an extremely low probability of failure out of 5 years.
That's amazing. So, and it sounds like it kind of happened by accident, like in a way. Is that fair?
It's
Or
a good solid design. It's just that
yeah,
the team
yeah,
and the
yeah,
decision makers didn't know
yeah.
anything
It
about
just
it.
was, yeah,
Yeah. One of the fun
interesting.
parts is I had my little test board and I was handing that around the table with all these manager types and program manager and stuff like that. And I'm explaining the test and where we're at so far, and here's our assumptions and blah, blah, blah. And one of them pulls out his keys and is trying to break the component off the board. And he couldn't. He was breaking the daughter card. It was breaking the surface
Something
of the
else.
board, and the solder
That's
would
amazing.
not let go.
Yeah.
And everybody's watching him and kind of not listening anymore. So I walked over, grabbed the board, and I just flexed it kind of in an S shape, just
Hmm.
crack, crack,
Yeah.
pulled the board piece right off. And said, depending on how you activate the failure mechanism, the probability of failure completely changes. And everybody
Yes.
looked at me like, damn statistician. Because I knew a lot about these components at that point. I'd been spending,
Of
3
course.
months
Yeah.
studying
Yeah.
it and looking at way too many X-ray images of them.
So did you find in that case that the next question, once everyone learned that, it's just practically impossible to break this thing, was the next question that, okay, so then where can I, shave off something to save cost because we clearly don't need this much of a safety factor in our
No,
reliability,
yeah,
or
no,
was that okay?
it was more the team that was making these decisions and was concerned about it just didn't have any information. So providing that, no, it is really robust. It's really solid.
Hmm. Hmm.
The cost savings came in the next generation of the product, which was more focused on
Ah,
cost savings,
yes,
because then
yes,
they could use a smaller circuit board. Because
yeah,
the gull
yeah,
wing for 250 connections is a lot of real estate just to get
yes,
all those
exactly,
things out
exactly.
there.
Yeah,
So
yeah, yeah,
this one, it's 250 or so balls underneath the package. And it was so we can move everything in closer to it. And
yeah.
so it did save on real estate. And that's where
That
the
makes sense.
benefit came from. It wasn't worth the time to redesign the board to bring in all that space and reduce it because all the mechanical engineering was done, all the location was done, everything,
Mm-hmm.
all the layout
Mm-hmm.
was done.
Yeah.
That was it was all there. But sometimes, yeah, you don't get a failure. Is it expected? If you were expecting failures, always, please, always design your test to get failures. Right? If you're not getting any of it, was it plugged in? You know, did you turn on the heat? You know, did you do something? Is it, you know, that's my first check.
Try turning it on and off again.
That's right. Was the connector not connected to it, you know, or something?
Yes, yes, yes,
Did it have the chance to fail? It's
yes,
really question the test. I don't think there's ever been a test where I don't set up, you know, surrogates and other things just to make sure it's in the right test conditions.
yes.
Um,
That's always my first yeah, my first question too is the test setup. I'm always suspicious if there if something has not failed, it's suspicious. You
that's
know,
right. It's
it's a
suspicious.
healthy skepticism. It's not that
That's
I
right.
want it to fail. It's just that it's a healthy skepticism. You expect it to fail, so
It
something's
should.
going on. It should, exactly. Something's going on.
Well,
Yeah.
it's to me, the failure is gold, right? It's the part that we can actually learn from. Is it the mechanism we
Yes.
expected? Did it occur about the time frame we expected? Did it fail the way we expected it to? Did the symptoms to the customer appear as it would it be expected? On and on and on. It without a failure, we're pretty blind. Now, there are things you can do with it if the testing or the conditions were real, right? If we give it to a customer and they don't plug it in, and it hasn't failed, well, it hasn't had a chance to fail yet. It's still in the box, kind of thing. So
Yes. Yes.
there's not a lot I can do about that. The other side of that is sometimes not failing actually gives you information going, maybe we're missing a different failure mechanism. Maybe we're set this
Mm,
test up to focus on, say, cycle time, the cyclic wear of something.
yeah.
Maybe it's a different failure mechanism we should worry about, a different slope on a curve that we're not seeing. The other one is, so what is your definition of failure? That's one they ask the vendor all the time. Well, we had no failures.
Hmm.
Well, what do you mean?
Yes, yes.
Well,
No,
we don't
it
count
doesn't
those.
it
That was a
doesn't fail.
manufacturing defect. Or that was a, you know, it failed
Ah,
unlike we
yes.
like it to. So we put a new part in, and at the end of the test, they were fine.
Yes, that's one of my favorite ones is that well that one was a it was not it was a non-conformant, so it doesn't count. You
Doesn't
know,
count. It
because
was a
that
quality issue.
doesn't
It
yes,
was
it's
a
a
quality
quality
issue.
issue, so it
That's
doesn't
right.
count.
Yeah. Like,
Yes.
okay, thanks. How many of those occur? Oh, about 15%. So you're shipping me 15% bad ones because you don't test them to failure, do you? And
And
they
it
look at
doesn't
me like,
count.
well, those don't count.
Yeah, they do. They do. By the way, I another t-shirt. Did it have a chance to fail?
Yeah, did it have a chance, Phil? There you go.
I like
Good.
that. That's a
Yeah.
good t-shirt.
Well, you could also do it with, you know, two colors and did it have a chance to succeed? You know,
Hmm.
there's both
Yes.
come in there. Yeah.
Both are good. Yes.
These are all
Yes.
going to turn into t-shirt design sessions, I tell you.
Yes.
But anyway,
Yes, they are.
sometimes we don't get failures and you still got to make a decision. You still got to move forward. The timeline still moves forward. And we talked about a couple of tricks or ways to think through that and deal with it. Yet other times it's, you know, did it have a chance to fail? It- was it plugged in? I think that's my favorite. Um, and
Yes.
how do you defining failures? Was it, you know, replaced just because it was a air quotes here quality issue? That wasn't a reliability issue. Like, okay,
Hmm.
I don't care if it fails in the first 10 minutes or the first 10 years. It failed. We need to deal with that.
Yeah, we need to learn. And you can and like you said, it's gold. You can learn from it.
That's
There's
right.
so much that can be learned from failed samples.
So I think the summary of today's is go out there and get some failures.
Yes.
Just break stuff, have fun. But if you
Yes.
don't, think hard about what's going on. Was it all these other conditions right and everything else such that either you're learning something, you can be pleasantly surprised your product's better or worse than you thought it was, or is the test and the conditions just not what you expected? So you can make adjustments and update your thinking and understanding of how your product works or doesn't work. But if you're enjoy having no failures and blindly go off to market with that. Not that I think well, I do think it is a bad thing. Let us know, what's working for you, what's not. How do you deal with not having failures in whether it's testing or in field data and so on, which is a good thing if your customers never see your products fail. That seems like
Seems like a
a
good thing.
that's
Yeah.
a good thing. Yeah, yeah.
Yeah.
It's really frustrating then when they say, "Oh, you got to make it better." Like, why? But if you're
Yes.
listening to this and you got a comment or a question, we always ask for your inputs and thoughts and stuff like that. Let us know. Head over to accendoreliability.com/go/SOR. A couple of ways to get in touch with us. Mojan and I and the other hosts of the show are available through LinkedIn and our About pages. So plenty of ways for you to get in touch with us. Luckily, we have had, if we count failures as receiving questions, we've had plenty of them. So we always appreciate that. And we'll be talking about a few more of them in our future episodes. But we'd like you to add to that stack, and so we can get you an answer and have stuff to talk about in the coming episodes.
Yes, absolutely. Please reach out with questions and comments and suggestions and challenge us.
Yeah, or just join the conversation. That's another way to
Yes.
think of it. All right, cool.
Yes.
Well, thanks so much, John. We'll let you get on with your rest of your day, and hopefully everybody listening stays tuned for our next exciting episode.
Yes, absolutely. Thank you.
Thanks. We'll talk to you later. Cheers.
Talk to you later. Bye.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.